All right, let's do simultaneous linear equations today. So what does it mean, simultaneous? Simultaneous means things are happening together, happening at the same time, at the same time. That's what it means for things to be simultaneous. So when equations are solved simultaneously, it means they're being solved at the same time. So what is linear? Linear means if you put it on a graph, you will have a straight line as a graph. Maybe so, anyhow. So this will be one of the graphs. When you plot any of these equations, you'll have these. And there are other types of equations. There are equations that will give you graphs like this. We are going to see all of those. Yeah, especially this one. Good. So this one is a quadratic graph. So we can have quadratic simultaneous equations. It's possible, but this time we are dealing with the linear ones. We have to understand the topic like that. Okay, so that's what we're dealing with now. So we're going to start by looking at the method of elimination. There are other methods, but we start with the method of elimination. So what does it mean to eliminate? Since we cannot solve any of these equations alone without using the other, there is no way that you can start by solving maybe for x in one of the equations by doing subject of a formula. It's not possible. Because if you take this one this way, for example, you have y here, x will be begging for an answer, y will also be begging for an answer. So you can't satisfy one and leave the other. So we have to find a way that, excuse me, that we will solve them both and get a solution that answers the two of them at the same time. That is why we're going to use a method of elimination, which is one method to answer that question. So what does elimination do? Elimination solves the problem of having to use both variables at the same time without cheating any. So they make one of them, you choose one, and it disappears for the meantime, temporarily. Choose a variable to disappear. Choose a variable, one, whether x or y, to eliminate. And for that to be possible, the coefficients of that variable in both equations must become equal, so that if it is x we choose, we find a way that this coefficient here, 2 and 5, will become equal, so that when we subtract, we obtain 0. Once we get coefficient 0, the variable disappears. So how does that happen? Let's see it. It's very interesting, man. So by elimination, let's start. The very first thing we do is labeling our equations. So we can call this equation 1 and call this equation 2. So if we choose to eliminate x, eliminating x, so make x disappear for a while, what shall happen? We'll be using 2 and 5 because those are the coefficients of x. So this equation 1 will be multiplied by the coefficient of x in equation 2 times 5. And equation 2 will be multiplied by the coefficient of x in equation 1. I call it exchange multiplication. So everything here multiplied by 5, everything here multiplied by 2. So what does that give us now? That becomes, so this means 2x times 5, 2 times 5 is 10, that's 10x. 5 times 5, that is 25, so plus 25y is equal to 12 times 5 is 60. I can call this equation 3. It's a new equation now. And then I come here, multiplying by 2 everywhere. 2 times 5 is 10, so 10x. 2 times negative 3 is negative 6y is equal to 2 times negative 1 is negative 2. Right, great. So See what's happening here now. This is where we want to land. Exactly. See what we have here now. 10x, 10x. So 10 and 10 can, when they subtract, of course, we'll get 0. Beautiful. So that's what we wanted. So you are perfectly set up for your subtraction operation. So we're taking okay, we need to call this equation 4. Okay, so equation 3 minus equation 4. So we do our subtraction now, roll our line. 10, take away 10 is 0, of course. You can call it 0x. Now, 25, look at this, be careful. 25 minus, this minus here, negative 6. So, negative 6, 25 minus negative 6, oh, whatever. 25 minus negative 6. So this minus and this minus join, combine to give us plus. So what we actually have here is 25 plus 6. 25 plus 6 is 31, of course. So 25y minus negative 6y, we found that to be 31y positive is equal to 60 minus negative 2. 60 minus negative 2, same thing happens here. 60 plus 2 is 62. So this is 62. Now, what do we have left here? We just have 31y is equal to 62. So we solve that. So if 31y is equal to 62, it means we can eliminate this coefficient by doing division. Over 31 is equal to 62 over 31. This goes here, goes away with that. Clearly, 31 is half of 62. So this goes here 2 times. So we are saying that the value for y is 2. Let's keep this. Y is equal to 2. So the next thing I want to do is to substitute this value y equals 2, which we have, in any equation. I choose equation 1. Why do I choose equation 1? I label it that same way because that's how I labeled it up here. Why do I choose equation 1? Because when I look at the coefficients, they look beautiful. I can use equation 2, but I want as easy work as possible. Good. So equation 1 rather. So wherever I see x, like here, I will write 2. Y rather. Wherever I see y, I will write 2 because that's the value we've gotten for y. So this equation 2 reads 2x plus 5y is equal to 12. So after substitution, it will become 2x, we're just copying, plus 5. But we have the value of y now, which is 2. So 5 into 2 is equal to 12. That is what equation 1 would look like now. So we simplify 2x, 5 times 2 is 10, plus 10 is equal to 12. Of course, combine like terms, this will go to the other side. This means 2x is equal to this 12 minus 10. So 2x is equal to 12 minus 10 is 2. And for those who can see clearly, we can see therefore that x is equal to 1. That's the value for x. So the final solution therefore is that x is equal to 1 while y is equal to 2. These are your solutions. We can prove this. Excuse me. These are proof. We take any of the equations and substitute these values. X for 1 for x and 2 for y. So come to equation 1, for example, which says 12x plus 5y. 2x plus 5y is equal to 12. So 2x, so from equation 1, they say 2x, what is x? X is 1, so 2 times 1, plus 5, what is y? Y is 2, is supposed to be equal to 12. So let's see if that actually gives us 12. So 2 times 1 is 2, and 5 times 2 is 10 plus 10. So this gives us 12, and that is true. Therefore, our values are correct.